Alright, class. Welcome to another episode of Bran Academy. As always, my name is Bran. I'm Mr. Wynn's twin brother. And today, we'll be talking all about circles. Okay, this is kind of the intro to chapter 10.8. It is our last section of the chapter. Okay, so this first part is really discovering where the formula of a circle came from. Okay, so let's do a little throwback here. Let's kind of follow these steps. Given the points x1, y1, x2, y2, write the formula used to calculate the distance between the 2 points. Distance formula. Okay, who got that? Okay, distance formula. Okay, is d equals the square root of the quantity y2 minus y1, quantity squared, plus the quantity of x2 minus x1 squared. Bam, just like that, okay? And just a reminder, this originates from, starts with a P, originates from the Pythagorean Theorem, okay? So I'm gonna do a little magic trick here. Watch this, boom. Okay, look at that, beautiful. Yeah, try to sketch this real quick, guys. I'm trying to save memory on my iPad. So anyways, okay, I'm going to briefly explain where this came from again. Okay, this is the line where we're trying to deal with. Okay, this is my original line. Okay, from this point here, this point is x1, y1. This point is x2, y2. Okay, so from any line, guys, you can always draw a right triangle, okay, to connect from one point to the other point. So the distance here, this bottom distance, okay, is actually x2, right? This whole x2 minus that x1. So this distance here is x2 minus x1, and the distance vertically is y2 minus y1. So if we try to use Pythagorean theorem, you want to recall that, right? A squared plus b squared equals c squared, right? My a right here is that x2 minus x1 squared, and that b is the y2 minus y1 squared, and that c, this is the hypotenuse. In this case, the hypotenuse is the actual distance. Boom. Now how would I solve for d? Take the square root of both sides. Okay, so again, reminder on how the Pythagorean theorem is related to the distance formula. And the fact that we're talking about circles, a circle is going to be a very similar, well actually exact formula. Okay, a circle uses the distance formula in it. Okay, so we will talk about that. Recall the definition of a locus. Not really recall. The definition of a locus is a set of points that satisfies certain conditions. Okay, so for example, sketch and describe each of the following loci. Okay? I think it's loci. The set of points in a plane equidistant from the 2 points PQ. Okay, so where are all the points that are equidistant to PQ? Boom. Okay, in the middle, obviously, equidistant. What about here? Equidistance, right? Basically, anything on this, what do we call it? Boom. Oh, shoot. Anything on this line right here, guys, would be equidistant from PQ. If I put a point right here, the distance from here to here, P to that point, Q to that point, would be equidistant. Okay? So the set of points in a plane equidistant from 2 points, P and Q, we call it a line. Okay? So all those points right there. Now the set of points in a plane equidistant from point P. So we just have one point. Okay, where are all the points that are equal to point P? Okay, so let's say this point here. Boom. Now what if I just like swing that point around, right? Like we're swinging it. So in actuality, what this is a, what we call a circle. So taking all the points in a circle right here would be equidistant to what we call the center, which is P. Okay, so let's kind of connect this here. So again, boom, all this equidistance, right? It's equidistance from that point, and that's your circle, okay? So let's see how we're going to connect this with the formula here. Okay, second page. So the definition of a circle, okay, when you're on your date, here's the official definition. The set of points in a plane equidistant from a given point called the center. So you need to have a center, okay? If there's no center, there's no circle. So once you have a center, and then you create all these points that are equidistant to that center. So look at number 3 here. Circle A has center 1, 1, and a radius 3. What are 4 other points in circle A? Okay, let's kind of use our brains here. We got to think outside the box. So the radius is 3, right? So from this point, can I go up 3? Boom, right? What is this point here? If I went up 3, it would be 1, 4. Bam. Okay, where else? Where else? Can I go over here to the right 3? Boom, that's 4, 1. And I can go down 3. That's going to be 1, -2. And then I go to the left 3. That would be -2, 1. Boom. Those are your 4 other points you can find just by knowing the radius and the center. Okay. So let's look at number 4. Use the definition of a circle to find an equation in x and y whose solutions x, y are the points on the circle described above. Okay. So here's a question for you guys. What is the distance from all the points here? All these points, right? The key thing is distance. Okay, we're the distance here. So let's just start by using the distance formula, okay, as my setup. Okay, so I'm gonna do this here. So we're gonna go x2 minus x1 squared plus y2 minus y1 squared equals d squared, right? Where d is the distance, right? So just a friendly reminder, you can always create a right triangle here, right? So if I wanna know what this is, right? Create that right triangle, okay? All right, so we know one of the points, right? I'm trying to get this x, y, right? One of the points is what? Is 1, 1. So let's plug that in. So it'll be x. So instead of x2, right? x2, this is x2, and this is y2. So I'm just going to plug it in here. So it'll be x minus 1 squared plus y minus 1 squared equals... so what is the distance officially? The distance is d equals 3, right? So 3 squared. Okay, simplifying this a bit. X minus 1 squared plus y minus 1 squared equals 9. Okay, so this right here, this relationship is actually your formula for a circle, because if you plug any of these numbers in, look, if you try to plug this in, you will get 9, right? It will actually work out. So this distance formula, since the distance is 3, right, in the end, when you take the square root, right, if you take the square root, all this right here, all this is a distance of 3, okay, forming a circle. Okay, so we're gonna get a little practice with this. I know it's kind of just like, it's new. So I'm gonna do part A, and then you're gonna do part B, okay? So sketch a picture of each circle, then use the definition of a circle to find an equation in x and y whose solutions are points on the circle. So right now, just plot anything you know. Okay, the center. Okay, let's graph that here. The center is 2, -3. 2, 1, 2, -3, 1, 2, 3. Boom, this is the center. Okay, so I have my center here. And the radius is what? The radius is 5. So let's just count this for now, okay? So let me just make everything here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, Should have probably gave you guys the graph. Next year, huh? Okay, so the radius is 5, so let's just do the easy points. So 1, 2, 3, 4, 5 right here. To the right, let's go 5, 1, 2, 3, 4, 5. Down 5, right here. Left 5, 1, 2, 3, 4, 5. Boom. Okay, let's see if I can do a perfect circle. Oh, that was so awful. Look at that. Okay, I'm trying one more time. Dang, I'm nervous, guys. Yay. Okay, that's pretty good. Boom. Okay, we'll work with that. Yeah, I can even just scoot this up a bit. Okay, so we have our circle. Okay, so now we know the center, right? The center is still 2, -3. And let's just say I want to pick this point right here. Boom. We'll call this point, right? This random point, we'll call it x, comma, y. So now we can plug this into our distance formula, right? So let's kind of use our distance formula here. So in this case, let's go x. Actually, I'll copy down the formula real quick. Boom. So this is our formula. Ooh. Boom. Okay. Kind of from Pythagorean Theorem, right? So this is my d, right? Distance. So x2 minus x1, in this case, is going to be x minus 2 squared plus y minus -3 squared equals d squared. In this case, what's my distance? We know the radius is always going to be 5, okay? So then simplifying this, x minus 2 squared plus y plus 3 squared equals 25. And that is your equation. That is your equation for this circle, okay? Boom. So please try B on your own real quick.